Okay, so we've got some questions about the effects of scaling. So to start with, in this question, we've just got a table of frequency data. So we've got to get the normal stuff, mean, standard deviation, and variance. So this is just a calculator job. So we have to select our statistics mode. We're not doing correlation or regression, so we need option one variable. We enter our x values, which is the top row, and the frequencies, which is the number of students. So now I've got all my data in, press AC, okay, press the option button, have some 1var calculations, and I've got to find the mean, so that's 9.74. I've got to find the variance, so that's this one here, s squared x, okay, or sx squared is 2.400, and on the next page I need my sx, which is 1.549, so that's 1.55 to 3 significant figures. Okay, so that's just generating the measures for the original set of data. Now for the interesting bit, we are going to scale the data. So the first approach to scaling is the marks are going to be increased by increasing all the marks by 5 marks. Okay, and I'm going to use my knowledge that multiplication affects both mean and standard deviation, but addition just affects one of the two. So I sometimes like to say that the new mean is a x bar plus b. This is for when we're taking the original x's and turning them into ax plus b. So if we do that to the original values, and that same thing happens to the mean, but the new standard deviation is just a times the original standard deviation, okay, without the plus b on. So that enables me to do the first two here. What am I doing? I'm just adding 5 to all the scores. So the mean gets affected by both multiplication and addition. So I'm going to do 9.74. I'm going to add on the 5. So of course I'm going to get 14.74 as the new mean score. But the standard deviation is completely unaffected by adding on the plus 5 because the marks are still just as spread out as they were before. They've just all shifted up by 5. And so the variance, which is the standard deviation squared, is also unaffected. Okay? But in the second follow-up example, I've now got every mark being increased by 50%. So what's happening to each mark? Each mark x is being increased by 50%, but when we do percentage changes, we need to think that 50% is a half, but we've still got the original there, so actually we're doing 1.5 times x. Okay, so 1.5 times the x values means that, applying this, the mean and the standard deviation are both affected by the times a. Okay, so for my new mean, the previous mean was 9.74. So 9.74, I'm going to be multiplying by 1.5. And when I do that on my calculator, I'm going to get 9.74 times 1.5. And that's going to give me 14.6. That's my new mean. The standard deviation, which was 1.55, okay, well that, unlike previously, is affected by multiplying by 1.5. So I need to do 1.55, okay, times 1.5. And that will give me 2.325. So 2.325 or 2.33 to 3 significant figures. I could do it knowing the more precise version of the standard deviation, because it's not quite obvious how to round that. I'm going to leave it in this form. And then for the variance, now variance is, so far we've just said standard deviation squared. So perhaps the easiest way to get the variance is to just take the standard deviation we've got and square it. So if I do answer squared, to that I'm going to get 5.40. But you may be wondering, okay, what should I do to the previous variance of 2.40 to find the scaled variance of 5.4? Well, it's not been multiplied by 1.5. And that's because this value is the standard deviation squared. So if I did want to come straight from the 2.4 to the 5.40, instead of multiplying by 1.5, I have to multiply by 1.5 squared, because the variance is the standard deviation squared, so the multiplying effect on the variance is the same as the multiplying effect on the variance when I do times 1.5, same as the multiplying effect on the standard deviation of times 1.5, but that being squared. Hope that makes sense. So I could actually put an extra rule up here that the new variance, okay, is a squared times the old variance. So if you're multiplying the data by a, the variance gets multiplied by a squared. So it's just to check our 5.4 figure that way. If I do the 2.40 and I multiply by 1.5 squared, I should get 5.4, and so I do. So, two ways to get this variance one. One is by just working with the standard deviation as normal and squaring at the end, and maybe that's the simplest way to do it. But later on in the statistics course, if you do more statistics, knowing that the variance is affected by the scaling factor squared might be a good thing for you to be aware of.